Hey there, Chem Squad. We're going to look at neutral atoms versus ions. And we're going to try to figure out which of the two is actually more stable. So let's look at what an actual atom is. So, for example, let's take a look at these two atoms. If we take calcium and chlorine, okay, calcium has approximately 2 valence electrons. Okay, and the way that you can figure that out is by looking at your periodic table, see which family this element belongs under. In this case, calcium is found in the second family, second column. Okay, um, so that means it has 2 valence electrons. So if I were to draw those 2 valence electrons on the top here like this, okay, we'll just make a note that these are valence electrons. Valence, valence electrons, of course, are electrons on the outermost shell, and there's only 2 of them. For chlorine, uh, when we're drawing Lewis dot diagrams, we can actually use different symbols to represent the valence electrons. But chlorine is from family 7, and family 7 basically have 7 valence electrons around it. Okay, so maybe we'll just write a note. Okay, so calcium is in family 2A, chlorine is in family 7A. Okay, so by looking at their family number, you can figure out how many valence electrons there are. Now, these two are considered to be neutral. Okay, they have equal amounts of protons as well as neutrons, and protons and electrons. They don't have a charge. When you compare this with an ion, okay, um, ions are basically charged particles. But in order for them to become charged, they either have to gain electrons or lose electrons. So again, we're going to have to rewind a bit and think back in grade 10. Calcium is considered to be a metal. Okay? Metals tend to lose electrons. I'm going to use E negative as my shorthand for electrons. So metals tends to lose electrons, whereas chlorine is a nonmetal. Nonmetals tend to gain electrons. Now, the whole point of losing and gaining electrons is to complete the outermost shell. So either the outermost shell has no electrons or it has 8 electrons. Okay. Atoms want to gain or lose electrons to achieve a full octet. Okay, that's the chemistry term for having a full shell of electrons, or like having a full shell of outer electrons, or having no electrons in the outermost shell. Okay, so it's called an octet because normally when we look at nonmetals, they will gain electrons until they have 8. Okay, calcium, they do actually have a full octet, okay, but not in this current shell. The current shell only shows 2 valence electrons, and instead of gaining 6 valence electrons to have a full octet, they will decide to lose 2 electrons because it's a lot easier. And when they lose those 2 electrons, the remaining electrons that they have actually fulfill this full octet situation. So if we keep this in mind, okay, let's look at what happens when these substances either gain or lose electrons. Okay, so we're going to stick with calcium. Okay, so calcium, we said, is a metal, so it's going to lose electrons. Now, when you lose those two electrons, we don't have any electrons left over. Okay, um, from grade 10, you should have been taught how to draw out a Lewis dot diagram. Okay, all ions tend to have square brackets around it. Okay, and in the case of Ca, because it's lost two electrons, it now has a positive 2 charge. Okay, because electrons are negative, and if you lose two, now you have more protons than electrons. So the overall charge is a plus 2. This is called a cation. So cations are positive ions. Okay, and they are formed by losing electrons. On the other hand, when you look at Cl, Cl already contains 7 valence electrons. Okay, all it wants to do is to gain one more. So let's just switch the color here. So this electron it has stolen from some other atom. Okay, so if it has gained that one electron, again we'll put some square brackets around it so that we can put in a charge. It's going to have a -1 charge. Okay. This is called an anion. Anions are negative ions. Okay, so the whole point of these atoms trying to gain electrons or lose electrons to obtain this full octet is that the full octet makes it stable. Okay, a full octet means the atom/ion is now stable. Okay. Think about your noble gases. Most people recognize that noble gases are stable. They don't react with anything. And the reasons why they don't react with anything is because they have a full set of electrons in their outermost shell. So what is actually happening here is that when we have Ca atoms, okay, becoming Ca2 plus ions, this is the more stable version. This is the unstable version of that substance. Okay, and similarly, when we have Cl as a neutral atom, it will have to gain electrons to become Cl negative. Okay, again, ions tend to be more stable than the neutral atoms. All right, let's move on to some reactions that involve formation of ions. Okay, because I've gone over now the whole process of metals losing electrons and nonmetals gaining electrons, we can now show it as a reaction. Okay, so I have 4 here for us to look at. The first one is lithium. Okay, lithium belongs in family 1A. So it has 1 valence electron. If you see an arrow with 2 blanks on the product side, it means that you are going to form some type of ion. Lithium ends up forming a +1 ion. Okay? To do that, it must lose 1 electron. So if the electron is found on the product side, this means electrons is lost. Okay, so whenever you see electrons on the product side, those electrons are lost. When you look at calcium, think about, again, how many valence electrons does calcium have? Calcium belongs under 2A. Okay, when it loses electrons, it will lose 2 of them. what's remaining after it loses those 2 electrons? It's your calcium cation. Okay, so again, electrons lost. Now, both of these are examples of metals undergoing ionization. Okay. If you look at the next two, oxygen and chlorine are both nonmetals. Okay, so they're going to gain electrons. That's why you see a blank spot on the reactant side. So oxygen is family 6A. It has 6 valence electrons already. In order for it to be stable, it needs to gain 2 more. So we put the 2 electrons on the reactant side. This means electrons gained. So if you see the electrons on the reactant side, which is the left side of the arrow, electrons are being gained. The product, after gaining those 2 electrons, is to have an anion. So now that oxygen has 2 extra electrons, therefore it has a -2 charge. Similarly, for chlorine, we know that it's in family 7A. It has 7 valence electrons. It only needs 1 more electron to be gained. Okay, so in both situations, electrons are gained, and it now becomes your chlorine anion. Okay, so this is just a very simple way of showing the reactions that I have up here with the Lewis dot diagrams. Okay, the Lewis dot diagrams does provide a better visual, but we can't be drawing Lewis dot diagrams all the time. Okay, it just takes up too much time. So sometimes, if we have to show the formation of cations or anions, we just use a simple ionization reaction. So hopefully that helps. That's all I have for now. See you soon.